Problem number 78. A parallel plate capacitor is filled with a dielectric material having resistivity and dielectric constant R. Okay, so that material will have some capacitance as well as some resistance. The capacitor is charged and disconnected from the charging source. Okay, the capacitor is slowly discharged through the dielectric because there is an inbuilt resistance in that capacitor. It will start discharging through that capacitor, through that resistor, so that the time constant of the discharge is independent of all the geometrical parameters like plate area or separation between the plate, and then we need to find that time constant. It's a simple but interesting problem. Let's see. I have created a block. Inside the block, I have represented this resistor and a capacitor. Actually, what is happening is, let us say this is the whole capacitor, and there is an inbuilt resistance between this and this. So there is a capacitor because there is a separation between these two walls, and then there is a resistivity between this. So when you charge, let us say you give a positive charge here and a negative charge here, and then you remove this. So this whole charge starts discharging through this resistor. In other words, even though you are seeing out of this box like this, what is happening is there is a discharge current flowing like this, and we need to find out that this charging time constant is independent of the material, the plate separation area, separation and the area. So for our sake, let's say it has an area A and a separation of L between its plate. Now the resistance of this structure will be, which we represented by R, let's say here, is given by R is equal to rho L upon A. And the capacitance of this structure is C is equal to epsilon 0 K A divided by L. Now the time constant will be given by RC. So we just need to multiply this term with this term. So we will have rho L upon A multiplied by epsilon 0 K A by L. A cancels, L cancels. We get the result rho epsilon naught K. That is the time constant. And after this much of time, the whole capacitor will lose its charge. So even if you have a capacitor and if you charge it to a certain voltage, if you use a multimeter to measure the voltage after some point of time, you will find that there is no voltage on that capacitor, because internally it is discharging, even though it's very slowly. Even though the resistance is very high, it's not infinite. It can be 10 megaohm, it can be 20 megaohm, but there is some resistance through which this charge is discharged, and eventually the voltage on this capacitor loses all its potential and charge.